Here's a solution to problem number 1. Find the volume of the truncated pyramid with a square base. Note, the 3 mm is the distance from the center to the edge of the square at the top of the figure. So what we're going to do to find the volume of this truncated pyramid is envision having a whole pyramid. So now we have this large pyramid, the whole entire figure, and what we're going to do is find the volume of this small little pyramid on top. We're going to take it away, and that will leave us with the volume of the truncated pyramid. So if I'm finding the volume of a pyramid, I know my formula is 1/3 times base times height. So when I look, we were given that these were square bases here. So I know the area of the base of each of these pyramids. Here I was given half of this was 8, so 8 plus 8 is 16. Here I also have 16 because it's a square. For the top base, the top pyramid, we were given half this distance was 3. So if I double 3, I get 6 times 6. So the problem here is I don't know the heights of the pyramids. So I have to first go through and find the heights of the pyramids before I could find the volumes and subtract them. So what I'm going to do is use similar triangles to find the heights of the triangles. For the top one, I'm going to draw a small triangle here. It is a right triangle and it's hard to see there. But there's a right triangle. The base of this triangle is 3. The height's unknown. I'm going to call that H. Now for the larger pyramid, I'm going to also draw a right triangle. So the base of this one's 8. The height is unknown, but I know it's 15 more than the height of the small pyramid. So I'm going to call the height of this green triangle H plus 15, because there's 15 more. So from here I could go through and set up my proportion. Here's my proportion. I have 3/8. That just came from the bases of those two similar triangles. And then I have H over H plus 15. Those are just the heights of the similar triangles. So from here I just have a proportion. I need to solve it. So I'm going to cross multiply H times 8 and then 3 times the quantity H plus 15. And I get the following. Now I have to distribute because I have parentheses on the right hand side. So I'm going to take 3 times H and 3 times 15. 3 times 15 is 45. So I get the following when I distribute to remove those parentheses. 8H equals 3H plus 45. To solve this equation, I need to move all the h's onto one side of the equation. So I'm going to move the 3h over to the left. So the opposite of a positive 3h is subtracting a negative 3h. Just subtracting 3h. I just said it both ways. So here, 8h minus 3h is 5h. 3h minus 3h is 0. And I need to bring down that 45. I get the following. 5h equals 45. Divide both sides by 5. 5 divided by 5, those 5's cancel. You're left with h. 45 divided by 5 is 9, so I get h equals 9. So the height of the small pyramid on top is 9. So therefore I know that the height of the larger pyramid is 15 more than that. So if I take 9 plus 15, I get 24. So 24 is the height of the larger pyramid. I'm just going to call it height, and I'll label it L for the larger one. So from here, since I know my heights now, I know the area of the bases, I could go through and find the volume of the pyramid. So let's start with the large pyramid. I have the following. I have 1/3. And then for my area of my base, I did 16 times 16. The height of that large pyramid was 24. When I multiply this all out, I get 2,048. Now let's move on and find the volume of the small pyramid. Again, I'm using 1/3 times the base times the height. So 1/3, the area of the base of that small pyramid is 6 times 6. The height of that small pyramid is 9. When I multiply this all out, I get 108. Since I know both my volumes, I can now subtract those volumes. So 2,048 minus 108 equals 1,940, and my units are millimeters cubed. And that will give me the volume of the truncated pyramid.